Hello and welcome everybody. So you may be a little bit surprised seeing this slide layout because it's actually not my company's layout, but this is actually from a user conference, which is an annual conference that is happening in Europe, which is called the User Conference on Advanced Automatic Testing, UCAAT. And there I've given this as a tutorial. So basically, this is a bit modified version of that talk, slightly modified, but obviously, as you can see, this was not in Helsinki, but rather in Paris. So, let me take you on this journey here. You may be a little bit surprised. I don't know how many of you are working in the testing field per se, but especially I've worked at Nokia for a couple of years in the Nokia Research Center, and everything was about test automation. But so it may be a little bit funny to see we're still talking about manual testing, but this is what I will be talking about. So a little bit about myself. So I started in university, looking at modeling and simulation and so-called model-based co-design of embedded systems. Then I came to Finland and because of my wife, started working at Nokia, so the cliche was perfect. I started the research center, and basically there people were saying, your modeling stuff, it's all good and fine, but actually we need people and test automation, so why don't you start working with TDCN3? And so it was, and I spent the next 5 years in Nokia developing systems, actually working with also the network side and the mobile phone side, and helping them to deploy TDCN3. After that, I've had a 3.5-year intermission in working on the standardization side as a local resident testing expert at Etsy. Before I then joined in 2010 Conformiq, and this has been my longest career step at Conformiq. So Conformiq is down the road from here in Espoo. And it's a company that has developed a model-based testing tool earlier on, and now more or less we're working on any kind of products that are helping to automate your automation process, your test automation process. And basically there I've been gone quite quickly to the CTO role, but my main work there is acting as the product owner for various enterprise IT products. So overall, just as a background for this talk, I've worked by now for about 18 years with model-based testing and test automation. So what I want to go through today, maybe 15 minutes each, where are we today? And here I want to say very clearly in enterprise IT, it's a little bit different world compared to, for example, what we have in, let me just fix this up. It's a little bit different world than the telecom world, but I will explain that in a moment. Then I want to talk about the evolution of software testing, from manual testing to automatic test design. It's a big topic these days. Then zoom in a little bit on the model-based testing part again relatively quickly, and then maybe the stuff that will interest most people in here is like, what are we seeing now on the horizon? Not even on the horizon, what we're seeing happening now in the test automation world regarding artificial intelligence entering the scene. So where are we today in enterprise IT? Now, I don't know how many people of you know what is enterprise IT. Basically, we have kind of two camps, two worlds of testing. The one world where I was born into was where you do R&D and you do testing of your product, so what you're doing here at Nokia, right? But then there's this other world, which is really another world with other conferences, other certification schemes, other rules, other definitions, which is called enterprise IT. And that basically means that every company, more or less, in any kind of sector you can think of, especially of digitalization, has to also worry about testing stuff that is not directly related to the product, right? So even for Nokia sells their stuff, or it has a website running, who tests this stuff, who implements this stuff. It's not really in the company's interest to invest heavily into this, right? The testing there is done very differently. Their testing is a pure cost. It's not part of our business, right? And this is not just like this in Nokia, anything, you name it. And for example, BFSI, which is the insurance business, banking, right? Oil company, you go to a gas station probably once in a while, right? All these people have websites, all these people have logistics, everything runs via the web, everything needs to be tested, everything needs to be working perfectly. And you will probably see in a moment why this is actually a very big field, and it's very interesting to understand working, let's say, in a telecom, that there's really completely different world out there. So how this whole thing started is that I was at a workshop in Milano, I think it was, and there was this question. They made this online poll where they had all these people from different disciplines in the room, mainly test managers. They were asking them, so, how much of your today's testing have you actually managed to do automatic test execution with, right? And I mean, I could almost have that poll here again and just ask you actually in your projects, even for research and development, right? How much of the testing actually are you automating today? I can only talk about Conformiq itself, right? So we develop a tool, but we also need to test our tool. Yes, we have continuous integration. Yes, we build daily. But does it mean that we do all of our testing automatically? Maybe not, right? So the question is, where are you in these figures? Now, the thing is, when we did that poll, and this was Europe, right? The answer was less than 20%. Are these people expecting that they're doing automatic testing? Now, for somebody who's coming from the telecom space like me, promoting TDC and 3S and test automation language, right? That was like, no way, this cannot be true, right? We have been doing automation forever. But actually, this data kind of reoccurs. So next thing that we have done is we have taken a look at the overall spendings in enterprise IT testing. And that's a lot of money. That's a lot of money. We're talking about $150 billion a year are spent on testing enterprise IT systems across the world. Right? That's a big number. And what this CAGR means is this is growing 14% every year. Now, this data is from 2017. We did it last year, right? So probably this year, this market has already even increased further and further and further, right? And then when we look at the breakdown of where do the people spend their money, right, then we see that actually, again, we get to this magic 80-20, right? So 80% of our testing, expenses are made on manual testing, and then when we come to automated testing, it's this 20%. We still have a lot of work to do. And even if you break that down further, especially for tool vendors like us, this was very interesting, then we get to $3 billion in terms of tool spent around automatic testing. And then, just for the test execution alone, we are basically down to 1% or something like this, right? So, many people have asked, where you have gotten this data from? So in the bottom, I have put here some kind of references, but we have done, analyzed a lot of different research to come up with this. But the thing is, we have to just come to terms, even as automation experts, that manual testing, there's still a lot around. So then, of course, the other challenges that we're facing also in enterprise IT, probably as you do also in R&D, is that, everything is going faster. Everybody is trying to move towards, working in an agile way, sprint-based. I don't know about you. Our sprints are in a single week, actually, that we are making, new releases every week. And have testing every day, all right, and roll out more and more the product, right? And this also is another thing that we've just seen 80% of our testing is manual. Like, how can we actually be able to produce products, right, in this way when 80% of our testing is working like this? And then, of course, there's the relatively old story that's still up there. Yes, everything's becoming more complicated. Everything needs to go faster. Finally, here a slide from the kind of this World Quality Report, which is a report published each year. I think it's a mix of Capgemini, Sogeti, and what is it, Microfocus or somebody these days that kind of query all of the enterprise IT space in terms of where is their shoe hurting, what are the new trends, etc. The funny thing, I did not even put this here. What they've put, the number one thing this year, actually, or last year, was to go towards automatic testing and model-based testing. But anyway, we see some things here. What is it that executive management wants is, shift left, find defects earlier, but at the same time, people are reporting, right, we don't have enough time to test, right? So we need to come out earlier. There's, again, product quality improvements, implement quality checks early in the life cycle. A lot of these things add up. Okay. So, okay, it's a simple summary. Of course, we want to do everything faster, we want to do everything better, and we want to do everything cheaper. So let's do a quick look at the evolution of software testing. So this is actually some data that I, quotes, ripped off a good friend of mine, Bruno Lejar, and also Mark Utting. Believe it or not, in 2006, they basically put the groundwork for this pyramid. This is now, 13 years ago. They published the book that had that data in it. So this data is actually relatively well known. But anyway, it still holds today. What the pyramid is trying to say is basically how much effort is needed in order to spend in order to produce executable test cases and reproduce them. So we're going to review these things from the bottom up. We're going to review how manual testing, about manual testing, going to kind of the script-based approach, going to keyword-driven, then 2 different forms of model-based testing. And then finally, in the next section, we'll talk a little bit about how AI is going to most likely disrupt this whole picture, right? Because, I have a lot of people, usually when I show them this pyramid, they're going, Stefan, well, we here, how can we get to the top, right? Is there some kind of an accelerator to get there? Because, do I need to take each step as a time in order, to advance or mature in my testing, in my test automation? So this AI brings in a very interesting new constant that can enable us, to kind of jump some levels, even possibly, in this pyramid as we go further. So about manual testing, okay, we know about it. One thing is it looks cheap, right? But as we see, 80% of the costs are still going into manual testing. No matter if it's cheap, we're spending a lot of money on it, billions, right? Of course, we also know it's time-consuming, ineffective, and error-prone, but quite often we also have these limitations in test automation. For example, at Conformiq, right? When I look at our automatic testing pipeline, we don't have automated tests for our integrations, right? So when we are integrating, let's say with HP Quality Center or something, and we're uploading a test, right? Our testing environment right now handles our tool, but then when we have to interface and run another tool as part of the same test to checks that did it correctly upload all of the tests automatically, right? This part we still do manually today, right? And you can say, okay, that's, quotes, just an integration, but still it's a test we need to do to ensure that, yes, the tests upload properly. Yes, so they're still not yet replaceable, and yes, and it's a easy method to kind of get to tests when they're hard to implement also. And there's also this form of exploratory testing, which at the end is based on manual testing. Then the next step in this pipeline is, okay, let's do automatic execution. Let's write everything in scripts and put it into code. A variant of this is this capture replay, where people starting to record what they're doing on the system that they're testing and then kind of generating a script from that, right? That's capture replay. We also know the drawbacks of that approach, that of course that once the application changes, which in the enterprise IT space is very common, right? Where, like I would say, maybe 70% of the testing that we have been involved in right now is about web applications, right? And they change very rapidly. That means you need to update the tests also rapidly. And then, of course, one problem we face, finding the people who can do this coding, right? And finding the people that can take over the coding when the guy that wrote the script before has left, and all of these things, right? Then, of course, we've been going further and been kind of saying, okay, maybe not everybody needs to be a really good developer in testing, right, in order to write tests for automation. So let's try to make it easy. Let's build building blocks, right? More or less keywords. Again, keywords are pretty, I would say, academics have been educating me that keywords and this kind of way of testing is around since the 80s. So what is new about that? Still, in every test automation conference, you find today people talking about keyword testing as being a great new way how to get more tests automated, because we can share artifacts and everything, right? But anyway, there's a bunch of benefits around this, but still, there is this thing that we still need somebody who implements the keywords themselves, right? And that's, again, a kind of expert team that we need in order to go out there. So then the next level has been with model-based testing, trying to break this and going a little bit more up to a higher level into the so-called world of the manual tester, the people who do not necessarily have coding skills. And then there was, for example, Etsy has published this kind of MSC-like notation to capture tests, which is called TDL, Test Description Language. I don't know if it's mentioned on here, but I guess not. But this is just one example. There's even other commercial tools that offer you to actually draw the tests using graphical symbols, filling out some kind of forms, and then basically, have a generator convert the diagram into code and then into executable material. So this opens up, again, the pool of users that can actually write automatic test scripts to a greater number of people. But still, also, the one thing here is, of course, the tester needs to say what to test, right? This is one of the things we're still doing, this manual test design, which leads us to this last level, which is the so-called automatic test design, or, where we use kind of models in order to specify functionality instead of specifying the tests ourselves, and then kind of making it having an automatic exploration of these models of functionality. So what you see here is just one way of showing this. This happens to be a surprise from our tool, but there's, again, other tools who have other ways how to draw similar things like this. The thing here is that this is about logging into a banking application and opening a new account, right? So there's this login phase where somebody logs in, and then the system has to take a decision if the users accept it or not, and then there's this possibility to either open a new account, transfer money, or request a loan or something like this. And here, this is now a kind of a picture, which not only, which is more than a picture, it's actually a model in the sense is that we can convert this, actually, we can generate tests from this, and we can directly generate automatically executable tests from that. Yes. And but again, it's a change of thinking, right? Because testers are used to think about the test themselves. So asking now the testers to say no, think about the functionality to be tested instead of the tests that you want to write, right? And then kind of, it's like in automatic testing, this model-based testing tool is there to basically work as a tester for you, right? So you tell it, here's my system, give me some tests and let me know, what is the best possible way of covering this with in the least amount of time, and knowing that everything is tested, right? Yeah. So here now there's some interesting other things in there also that, in Agile we talk a lot about waste, and also a lot of problems that we are usually facing in the test automation space is not only to get scripts, but to also get documentation that matches what the script is doing, right? Because what happens when you have implemented a test and you run it, and then maybe, you write the documentation around it, and then it comes to know like, oh, there's a problem in the test. Okay, we need to fix it. Well, people go into the code and fix it, but do they update the document exactly what they have changed or how they have fixed the test? No, because it's a lot of work. It's painstaking, and who likes to work on documentation, right? And even in Agile, even worse, like documentation, that's completely secondary, right? We should focus on building, releasable products. So the nice thing about this is that, when you work based on models, you can easily kind of cater to different needs, right? So you can say, I can generate the documentation as well as the script, and both are completely in sync. And it's one push of a button to get both, right? And there's no more manual kind of working and updating in X different places. Yes. So, and the idea here is, again, the idea was to enable, remember, 80%, right? A lot of manual testers out there in the enterprise IT space, they will not code tomorrow. I can tell you that. And it's not a solution to say, I hire new developers that will be doing the testing for me, right? There's also something involved here called cost, right? The way how these manual testers, what these manual testers are paid and what the developers are paid are worlds apart, right? So there's not just this alternative to say, oh, I just hired all these qualified people and my problem is solved. So we need to find ways how we can engage the manual tester also into the automation process. And this is where this is going at. And this is also going into, like now I can also go even to my product owner, to my business analyst, and I can tell them, this is what I'm testing. Right? If you have the developer coming, or if you have the test automation engineer coming with his Python script, to the business analyst, this is what I'm testing. What is that guy going to say? Well, good for you. I have no clue what you're testing, right? But here, at least here, this is a world that's relatively close to business processes. It's not the same. It's not the same. I want to say business processes are not enough, don't contain enough information to generate automatically executable tests. So there's a bit more behind this, behind the scenes here that you need in order to get this out. Okay, and then there's just finally, as a closure on this kind of overview of the evolution of testing, model-based testing, this term is floating around in a lot of ways and it has a lot of meanings. And we need to understand there's different interpretations, right? So when we talk in this presentation about model-based testing, we talk about it in the sense of automating test design. I've been also working at ISTQB in the model-based testing certification, for which there, by the way, is also a foundation level certification at ISTQB. And we had discussions in there with the model-based testing experts if it is considered to be model-based testing when I draw a model on a paper or when I have a model in my head and my hands, they start writing the test. Is that model-based testing? Or do I need to have a machine that actually generates tests? I mean, when you think about this term, everybody has their own kind of idea of what it means, right? But what we need to understand that when you go out there and you say, we're doing model-based testing, you need to be aware there may be different interpretations as to what that actually means. It just means there's a model involved and you're doing testing, but no more than that, right? So automatic test design has, on the other hand, a very clearly defined meaning, right? Because we are automatically designing tests, right? So automatic test design and model-based testing, they're not the same, right? One form of model-based testing is automatic test design. And regarding this, it's not just my opinion, but there's actually, again, a couple of standardization bodies who have addressed this and standardized these notations. So it's not just a personal opinion. Okay. So then let's look a little bit into this model-based testing as we've just learned something about it, right? So I don't know when you kind of have been in touch with model-based testing, but most likely you have done this. Now this is kind of a time scale that I could not really put well into years that it actually scales properly. So I've just given it some milestones. And so model-based testing starts before at least I was born, right? So that's how new model-based testing is. So my father even was approached in his job at IBM saying like, hey, we have this model-based testing, it will solve all of your problems and more, right? And well, he is now retired, but it didn't solve his problems back then. So anyway, but we have gone through a really tremendous evolution with this technology, and which we can call model-based testing. So this automatic test design only surfaced in around 2005 or something. Even Conformiq had an old tool in the 90s, which was actually working based on test models and which was just using Chinese Postman, graph traversal stuff to go like, look, here's a bunch of states and arcs, we can traverse it in some way, right? I mean, this has worked before, but then people started to figure out, well, we need a little bit more. It's not about the number of tests that matter. It doesn't matter if I have 10,000 tests or 20,000 tests. It's about what are they testing, right? Am I testing the right thing? This is what automatic test design is about, trying to find out, like, have I covered everything in an optimal way? Another interesting thing that I have some kind of illustrations about is like how we see how people have thought of models, right? I mean, in the beginning, this first wave, well into, this is up to UML, I would say, up to the 90s, it was really pure code, C++, Java. People wrote models as code, right? At least when I was in my graduate work, my first models for simulation were actually real code. Okay, then people came around, I have a great new idea. We use UML, it's really graphical, and it does everything for you. Okay, well, then we had this kind of phase where these kind of general purpose modeling language use one thing, one size fits all, one notation solves all of our problems, right? Now, this also did not really work because UML as such has never been, the graphical part has never been strong enough to carry itself fully for automatic test generation, but it needed to be complemented with other stuff like code, right? I will show that in a moment. And then, I would say the next thing was that people moved towards domain-specific languages. I would say this happened in 2005 around. And then, of course, another thing that is very important to see is that MBT 1.0 was about model-based testing is about generating test cases, okay? With 2.0, people realized that's actually not the real value. What MBT can do is it can serve as a link between the requirements and my execution, right? It's not just about getting great tests. It's about, creating scripts for execution. It's about uploading the documentation to the ALM system so nobody has to do that manually anymore. It's about linking the requirements, about getting automatic traceability, right? This is what this software development lifecycle tool integrations came up with, going directly to CI. Now this has opened a new dimension. That's why I'm calling it 2.0. And then the 3.0 was starting. There were still then people saying like, okay, we have models, we can upload, it's great to have all these artifacts, but then I always have to start from scratch, right? So I start writing a test from scratch, I start modeling from scratch. What is new, right? So we'll look at a little bit into this. And then, of course, there's the standards about what the technology is doing and what people are doing with it. Yes. Okay, so about this model-based testing and automatic test design, how it works is it is really a mathematical problem. So if you would unpack our tool and you would kind of dig down into the engine, you would find a world of Lisp-like language trying to solve formulas, right? So whatever these graphical models, they wind up to be graphical formulas. And then what we're doing inside is we're solving an infinite state space problem and trying to find the best way through a world of flows and data, right? And this is the key thing here, where, again, it's a search problem. And then, of course, another thing is about the data. And here, the one thing you should just walk away with is that in order to get the data to match up with the flows, you need something like constraint solving in your engine in order to understand that the data that the user has entered into the model is actually aligning with the flows and allowing you to actually generate tests, right? And this is what automatic test design is about. So reasoning and problem solving is part of automatic test design. And then, of course, there's this thing like we are trying to get coverage information. Did I cover all my equivalence classes? Did I cover my boundary cases? Did I cover my data combinations? Even mutation testing was one of the latest trends that are my tests strong enough to detect errors in mutations of my system? So I don't just try to generate from my system, but I create a mutation of my functionality that I'm testing and saying, this test set, does it still catch all the bugs when I introduce willingly a bug, right? So all of this stuff is also part of automatic test design, that you can tune what you want, right? And that this is not manual, but this is automatically done. And you can basically drive that as a tester instead of implement it in a programming language yourself. Yeah, and this is about these notations, just for those of you old enough. I still remember when I worked in the research center, I had a colleague next office who was really saying like, well, B is a horrible language, but Z is much better. So the first modeling notations which were used in automatic test design were functional programming languages. I don't know how many of you have worked with those. But then again, then we see that, UML came around, but the thing is UML on its own is not good enough, right? So for example, that state diagram still will require some code in Java or C# or some other programming language in order to specify the data aspects that are related to the functionality. And then there's this object constrained language, which is also very popular, which is a part of UML actually. So one problem that we've had, this is when I joined Conformiq, we had modeling front end like this, right? And the first thing I had is people saying like, oh, when I see this Java code, is this my implementation? Or is this my model, right? And then I said, no, this one is your model, even though your implementation is also in Java, but this one is a Java for your model, right? And that kind of started also kind of confusing people. But again, I think the world's gotten a lot better ever since we have been moving towards domain-specific languages. At least I had this big eureka moment when I was lucky enough to catch a talk by Juha-Pekka Tolvanen. I don't know how many people of you know the CEO of Metacase, a company from Jyväskylä, who opened my eyes. And he introduced me to this world, and I've never been able to leave it after this, right? He has showed me, like, it doesn't matter what you're trying to do. You want to do testing, fine. You can define yourself a language that you can express what you need, for your own purpose, right? And this basically, what I wound up doing is trying to find a language which gives me all these things that I need from a testing point of view. UML was designed for everything. It was not designed for testing. Then people started to force feed later on UML, like UML testing profile. But at the end, this is a language from the bottom up just about what we need for testing. And that has really changed everything. And we've seen that in terms of deployment. Again, this is a language people can even handle without programming skills. And they're actually programming, but kind of graphically programming in a way, right? So anyway, there's more information elsewhere. I don't want to spend much more time on it. The 2.0 was then when we started to have these integrations. So the big piece here was, yes, model-based testing is not just about test generation. The integrations are a huge value add. Automating the process in itself shaves off a lot. It's not just about the design in itself. Right, so this is when we started going to documentation, to ALM, execution to our continuous integration. We are also linking stuff from the ALM and kind of linking it back together. But still the problem was this, okay? So they said, model-based testing is great. Now let's get started. And then you looked at this. Okay, you got like, okay, we have this great easy language, but how do I get started? Right? And I have a lot of stuff. I have a lot of things in my head. I have a lot of information on my machine, but I still have to think about what I'm doing, right? So this is where, we started to look into, okay, how can we generate models from all the stuff that we're floating around, right? Okay, maybe we have some business process models available. I know they're not ready for testing. I cannot generate tests from those, but at least I don't have to redraw the same diagram looking left and right and copying that, right? Who wants to do that? Splendid work. Gherkin came along, right? Flowcharts, right? Business kind of assets. And then we have the test-related assets, that we can actually kind of reverse engineer from tests the functionality that they have been testing before. So coming from manual tests, which again is a huge legacy of manual tests around. Test plans from ALM. And then there have been UI recordings, etc. All this stuff we can reuse, we can import, we can generate a lot of artifacts so we don't have to start from scratch. Yeah, so this is, for example, how it looks like. So I have here this Excel test suite. Again, we're talking enterprise IT. Most of the stuff people have, the 80% is in these type of Excel files with manual text that people execute manually, right? So we can create some first model from that, and then kind of start, bringing this back out to the execution and using this step to kind of create the automation scripts. And while we're importing it, we can even get some data in terms of like, you will be surprised, but there can be copy and paste mistakes in here. I found tests in these tests that have just a different name, but the exact same amount of steps, or vice versa, even complete duplicates in this, right? When we have 10,000 tests, 20,000 tests, do we know how many duplicates we have? Most likely we don't. So, and then there's the other thing, Gherkin, right? This has been a big game changer. Gherkin also in test automation, get the business analysts engaged, but we have observed similar problems in the Gherkin. For example, here, just to show you, at the end, it's a wall of text, and you can still make kind of things. So for example, there's one test which is actually contained within another test description here. I mean, at the first glance, it's not really visible. I think it's this one. Yeah, these steps are exactly part of these steps, right? And this is, of course, an example. But again, we have gone through Gherkin, and we have found the same thing. So this is this behavior-driven development, right? And again, here from Gherkin, Gherkin are at the end, even though maybe it's not by the book, used to really describe test cases as well. And that's why we have adopted a similar approach and can even create these flowcharts representing the Gherkin from that. And again, the sky's the limit. A lot of the conversions I've not shown here. Okay, and this is a little bit about the optimization that we're doing. So for test reverse engineering, when we have some kind of a test artifact, be that Gherkin, be that manual test, yes, things like this, then test plans from the ALM, for example. Basically, we just normalize these things, read them in, I try to understand what are the test steps doing, where is there some kind of containment, and then we kind of compose this graph from it. So this has been around also in other technologies. I don't know how many of you have used or heard of SDL and MSCs, right? I mean, here we have had already some very similar approaches to kind of composing SDL models from MSC traces. So not rocket science, but it can also help here in kind of getting test assets reusable, before. At the end, the quality of the model will be different. It will still be a model of test cases. It will not be a model of functionality. But again, it's still, better starting point than saying I have nothing, I need to start from scratch. Okay, so now what has happened in 2018? Believe it or not, even though I've now tried to make you accept that this domain-specific modeling is the world's greatest way of doing modeling, there's now a push, especially from low-end tools, that really pushing, again, writing in prose, right? So meaning like even domain-specific things, you have to drag and drop, you have a bunch of existing elements, but I just want to write, right? Remember, these manual testers are used to using English mainly as a language for writing their tests. So now when you come to them, say, I have this great graphical modeling, and just kind of plug these things together, still they consider like this is effort, right? I would just like to write, and especially like how I want, not how you want, I want to write how I want, right? And of course, for a methodologist or people like me in my field, this is of course hard to accept, that no, we cannot all write like we want, because we want to go to automation and we need to have a clear understanding, clear sense of meaning, what it means, right? But it's anyway on the wall. These tools are getting used and people are happy using these tools or getting something out of these tools, and we cannot ignore it. And there's the other kind of 800-pound gorilla in the room with his name AI. That's also a big factor in this picture that you will see will affect this prose-based modeling. So, and then, so this is this perception again. And then, of course, what we also see is like when people use domain-specific languages like ours, I see a lot of people taking the back door, right? Of course, we give them concepts, click a button, fill out a form, click a hyperlink, validate, the buttons are enabled, the standard stuff, but then they go like, well, I want to see that the text color is green, right? How do I do that? Well, it's not part of the abstract language, but there's an extension point. If you want to say the text color is green, you can start to do that. But then they kind of start to figure out, oh, I can extend, so that means I don't like this, click a button, I would like to write it differently, right? So I can now start to use this backdoor to do everything, even that the language was designed for, to do it. And this is, of course, then again harming the automation side. So that brings me to the last section. You have almost made it, which is about this 800-pound gorilla, which is a lot of talk about artificial intelligence and testing. And I bet also within Nokia, this has been a topic. But of course, you open the newspaper, at least in the newspapers that I read since I don't know how many years now. Every day there's a story about artificial intelligence, ethics. We started with Tesla or something. Tesla hit another car. They were driving on the autopilot. Artificial intelligence. How do we handle that? Big excitement, everything around. I used to be very skeptic towards AI. I have to be very honest with you. Until I went to a workshop in a very faraway place about 2 years ago. And actually in this workshop, this was by a service provider, there was this video that I seen there that was called Humans Not Need to Apply, right? And it's one of these doomsday visions about how AI will start to drive cars for us, and it will start to make everything for us, and humans no longer will have a job, and they will have to figure out what they do, right? Because AI will take away everything that we do and overtake everything. And this video was actually done 5 years ago, right, or something. I have a reference in case you're interested. But, I was watching this video, I was just saying, bullocks. I mean, we are so far away from any of this. I mean, I don't know how many people have ever been in India. I go there once a quarter, so I've seen on one day an elephant, a horse, a car, cows, obviously, on the road. On a, big 5-lane highway, an elephant in the middle walking around. And then they're coming around saying like, oh, the Google cars will go everywhere and do everything, right?
Then on the other hand, I've heard people from California talking about, all these autonomically driving cars. They're already on the roads, and you can just walk around. You see this driverless car passing you by in California. So, I've not been there, so I cannot attest it. For me, it's just a story. But anyway, I mean, we all recognized AI is there. But already there, I've seen in that workshop 2 years ago how much people are doing, especially in enterprise IT already with AI. And that's what I want to kind of update you on. But the first thing is to go back to textbooks, right? So artificial intelligence is not something that was invented 5 years ago, but actually it has been a course since the 70s in many graduate programs. I probably bet that a lot of people in this room have taken such a course and maybe even still have their textbook like me, right? So these are kind of classic definitions that come under what is AI actually as a discipline, artificial intelligence, right? So it is, for example, about fuzzy and probabilistic logic is part from AI, classification techniques, search and optimization, expert systems, and then, of course, deep machine learning, right? So if we think about it, yeah, fuzzy testing, right? Fuzzy logic testing, I've heard about this before, right? Classification, equivalence classes, search and optimization. I think, some of this stuff sounds familiar. It's just that this deep machine learning, where we kind of start figuring like, okay, I mean, that I don't know. In testing, where have we used that and why would we use that, right? But the thing is that a lot of these artificial intelligence techniques have been already around and used since quite some time, especially in automatic test design, right? So saying that we have never used AI before is, for me, not really a correct statement. But the kind of issue we have is that now in the popular talk, right, the term AI is just reduced to mean deep machine learning. And deep machine learning meaning a machine learning where the user is not directly involved. It's basically going back to this concept that we had in the 90s about optical character recognition, right? You give a bunch of training sets and the system learns, and then it can recognize what kind of a document you have scanned, right? I mean, maybe I'm oversimplifying it, and maybe I'm stepping on somebody's toes here, but even these things, they have been around, right, before. So where's the things that we've been seeing AI come up? So the one thing has been robustness testing. Actually, there was a conference, HUSTEF, right? Szilard has been and is still involved in the conference organization, testing conference, drawing, I think, where are we now, 800 or 1,000 people? Around, let's call it even, yes. So a lot of people come there, and I remember this keynote saying like, oh, AI is going out in testing, and they've talked about this Google Monkey, right? Now, Google Monkey is this program that whenever you upload an Android application, it starts testing it and starts to find out if it can break it. So basically, it tries to find out, is there any null pointers, any kind of exceptions the thing throws, is there any smoke coming? It's classic robustness testing. And this thing does not test really anything. It just tests, can I break it, right? But I mean, people are walking around and saying like, here, AI solved as a problem, no human involved. We just upload the app, it's tested, we're done, right? Oh, testing problems are solved, but it's not really quite correct. So anyway, and as we can see, people have actually gone, sorry, why is this no longer working? Okay, anyway, Google Monkey was one thing. The thing is, after that, people started working around because they've seen actually it's not very effective, right? Especially when you see like how many steps did it needed to take before it started breaking something. Okay, Google has a lot of servers, so they don't maybe care so much about their resources, but it took a lot of time compared to other approaches until they found actually something, right? And what is the trick about these other kind of versions of these robustness versioning tools based on AI technology? This is because they're starting to involve the human, right? The human starting to give hints where it should look, right? So I think this is where we will start seeing AI emerge stronger and stronger, is when AI assists humans to do something. But this vision to replace the human, I think there's various kind of talks all over the place. I mean, it also has to do with computing power, right? And we still have some ways to go before we can actually replicate the computing power of a human brain in a computer. That still has luckily taken, I think, 40 years if we follow Moore's law. But I mean, this is more something that I think what we're seeing there. There's also, for example, people who have started to combine, let's say, online model-based testing. So there's a test automation tool vendor that has been starting to say, okay, I have these models and I'm exploring them, and I will use actually learnings from the execution in order to generate my tests. So I will not just blindly look at the model and say everything is equal, but I will consider in my test generation, I have been getting failures on like buttons being disabled or something. So let's pick the paths that, check these buttons all over the place, right? Because I've had one mistake in this, right? So it uses learnings from the test execution in the test generation. This is already sold as AI. This tool has AI in its name. Okay. Yes. And yeah, with this, no human required for the test execution was just about this robustness testing. Okay. Then this was the kind of talk that where I first got in touch with AI. A lot of people, especially service providers, have done since a lot of years a lot of work how to handle the analysis of test execution results, right? So this is basically going into data mining. I think Nokia also has this kind of challenge. Like I have 20,000 tests in my regression test suite. And do I really need to execute every single test on every single run? Right? How should I go about this? There's some very interesting stuff out there. And there's this guy, Venkata from Accenture, I've put a YouTube link there. He has been walking around with this idea, test less, test right. I mean, it goes, I think, into an interesting direction. For example, if I can tell you already in advance that a test will pass, why should I execute that test even? If I know it will pass, what is the knowledge that I'm gaining just by executing a test that I know will pass, right? And that we should maybe kind of collect data that allow us to predict which tests will fail and will pass. And let's prioritize at least the tests that will fail and get to information much quicker. Of course, that will also change the entire test execution results, right? And every manager will have to get used to that maybe it's no longer like 80% pass and 20% fail, but all of a sudden, you will get these high numbers, right? But this is some interesting stuff anyway. But the funny thing is that I've been at this talk where some guy has been doing a lot of work on doing statistics of what has actually introduced bugs into the system. And you know what it was? What actually triggered most of the bugs? I don't know. Does anybody have an idea? What is the most frequent use of bugs actually entering the system? It is actually the guy who has checked in the code change, right? So that he has found the most correlation to bugs. So that's how simple, quotes, our problem could get. I don't know how many people are even checking SVN check-ins to the system code before they start testing, right? I mean, that's something very basic. We know all of the commits, right? So that also already tells us, like, is our test even covering that code? Then maybe I should execute it, right? And then the other thing is maybe even that guy does not have a good track record. Maybe it was not his best day. So, I mean, actually, these kind of, it's not so much the ambiguous specification or the things that make things really break, but, it's an interesting fun fact that it is the guy who has been committing the code that, at least in statistics, seems to show up quite well. Anyway, so this is about predictive analytics, and this can also be, of course, driven by AI because we have huge data sets. I mean, I cannot ask anybody, hey, look through these 20,000 logs and give me some ideas. No, this is where we're using kind of all these data mining techniques and learnings, as part of analyzing these data. Okay, and then again, it's about this picture here more comes about the visualization. Where do we hit the defects? Now, obviously, this is a kind of an artist rendering. This is not from a real system. But the idea is like, let's think about like, how do we handle seeing what 20,000 tests have done in my last execution run. And it's more like, a cockpit in like an airplane fighter, like, you're trying to see, you have different representations of the data about how your tests have executed to reach conclusions instead of just kind of going up what is pass and fail, right? So this can give you more hints, right? And then of course there's the more interesting thing is like which one of these failures are actually real failures, or they're just the symptoms of a defect, right? I mean, because an error does not mean multiple errors may be all caused by the same reason, right? So it's this holy grail of root cause analysis that I know a lot of people have been banging their head against the wall, and there's, of course, still work to be done. But anyway, people are using AI also to kind of make that happen even further. So again, a lot of work out there already today, right? That across a lot of these service providers has been, this is how they usually approach also, their customers, and giving them kind of the benefit that, look, we have a really good analysis framework that we can actually make your testing much more effective. So I don't know about you, but I'm actually from functional testing, so all this stuff is great, but I'm still caring a little bit more about what can we do in functional testing and test automation to use AI, right? And here's this thing, right? I mean, the tool vendors for all these test automation tools, especially in the enterprise IT space, they have been doing great advances to make the specifications of tests dead easy, drag and drop, graphical, anything, you name it. But we're still stuck in some really fundamental kind of very basic problems, right? I mean, if we can, for example, get to a model, right? After that, we're done, right? We just need to get to this graphic, but then I have just these loose sentences. And the big step where I'm still requiring a human is to say, like, well, if somebody reads this, they should create this type of model, right? And the same thing goes for, let's say I'm not using modeling, I want to just make an automatic test case out of this statement, right? Enter the username and password that I know in my scriptless testing environment, I just need to add these 3 rows, and that will actually execute that test, right? I mean, it looks like we're here at like this 5%, 10%, and after that we're rolling, right? So the thing is that here, for example, one way of doing this is here also to leverage the AI part and kind of using AI as a way to learn language, right? So, I mean, I don't know if you've gone to your airline side lately, but there's always, this word in the, what was it, in the 90s, there was this annoying guy always coming back and can I help you, this clip, this paper clip, right? I mean, all these kind of helping tools, they're not humans, right? They're actually programs that have been programmed to talk with you, right? And I mean, the distance is no longer so close that saying like, well, at the end, this is just like me talking with somebody, right? And a lot of work has been done on natural language processing, that we can use natural language processing to kind of create the mappings from the natural language text to the automation, right? So basically, we tell it that whenever you read about a username or you read about a password, that means you need to fill out these fields, right? So right now, this is the first generation of this kind of AI stuff, which is still rule-based, so where we still have the human involved. And for me, I'm still thinking that's a strength and that's not a weakness, right? So basically, that the human can control and monitor like how the system is converting sentences or language into automation. So basically, the steering wheel of this is like at this point it's, for example, an Excel file where there's just a bunch of rules listed. It reads the manual test, it tries to match against the rules, and based on those rules, it creates the script, right, for automatic execution. So this is a really big thing, because now basically we're starting, remember how I said, like now we're seeing even in the modeling world, people are turning to pros, right? I mean, this is just here legacy, right? Thousands of legacy tests are sitting there. And of course, we don't know even if all of them are still executing and everything else. But I mean, with this, we get a very quick path to automation. So this is one solution that's out there. This is again just a little bit kind of drawing this a little bit up. So where you can, for example, one approach is to kind of take about the words that we're hitting, as to how that actually then, what kind of an action that's mapping to, and how to identify objects and parameters that are linked to it. There's a little bit more to it. This is an example from Selenium. But I mean, this can be, of course, scaled to more or less any kind of target language if you're using robot for execution, UFT, or whatever other kind of test automation tools you have, custom Java, Python. the target does not really matter, right? The trick is how to understand language. And here we're getting to this, of course, again, and you have to understand everybody's using their own language. You have two manual testers in the same team. They will write their tests slightly different. But the trick is here is we can, with this technology, we can kind of, we need to, of course, also tune it first, right? I mean, we can give you a kind of a first basic English version that you start with, but then it's up to the tester to kind of train the system, accumulate rules, and as you go, you can establish the vocabulary in order to do these transitions, right? And then you have a very powerful tool that you can use across, even organizations. But yes. So, and the interesting part is, this was just what I just showed you beforehand. This here is an approach where I have a manual test in a test plan in ALM and I execute it manually, right? And now I want to go to script or to some execution tool. And now when I'm going further, I can also say like, okay, maybe what I want to do is I want to even create my models, right? In a prose manner, and then just actually export the generated tests coming from automatic test design and go completely via prose. We are not there today yet to do this, right? But actually this is how, at least in Conformiq, that idea got started, right? Because we had a lot of issues with textual specifications in our models, and then we kind of started to come up with this approach involving AI to do it. And let's say this is the kind of, this is my last slide. So this is what I'm calling no longer MBT. This is what I'm calling Test Automation 4.0, right? So basically, I see us moving, still being able to leverage automatic test design also in the future, but seeing that AI will especially come in the integrations up strong, and that we will see, again, the modeling going to prose-like language. And of course, what's also there, and which is not yet here in the slides, because I've not played around it myself yet, is that even deep learning is coming to this kind of automation world, right? So that people actually, a lot of commercial tools have emerged, let's say last quarter, especially in the US, that are all basing that are offering techniques where you can actually do these mappings actually without human interactions, just based on training, okay? So no human interaction is also a wrong statement. What it means is when you use these autonomous systems, that means you need to put them away in a room, right? And learn based on boatloads of test data. So you need to give them sample manual tests, a lot of them, right? So that it can train itself on this data and then make predictions when it's reading in the next data. So this is kind of also where Conformiq is doing some research into as its kind of second generation thing to go towards the autonomous kind of automation generation. Yes, and that closes basically my talk. And I would be happy to have any questions that people may have on the topic. Thank you.
Stefan, you mentioned that at least you are mostly concentrating on functional type of testing. How does this fit into a kind of security threat testing of attacks?
I'm not so much in that field, so I cannot really answer. But I mean, for me, the robustness testing is kind of in this direction. I mean, when I look at at least in the side view mirror, I've always looked at Conformiq and solutions like this that are doing fast testing, right? I mean, I think basically I would probably see if they are doing anything in this direction maybe as well. But I mean, again, even this fast testing in itself is already AI techniques, technically speaking. But I mean, question is, do they use learning now to maybe make their systems, to like, for example, to learn attack patterns or something, right? I mean, the thing is with this AI and testing, we really need to think out of the box, right? We need to think about the testing problem and see where does the technology make sense, right? And the technology makes sense where we have enormous amounts of data, especially this deep learning, right? It always requires you need to have enormous amounts of data available that you can learn from. And then basically what the deep learning will do is it will give you good guesses as to what it thinks should be next, right? So also AI never gives you a question back saying like, I'm 100% sure this is going to be this way. They're going to give you it's 80% true or 50 or 20, right? And then you need to kind of see what's the threshold that I'm working with. So it does not give any, direct solutions, but still, I mean, I just want to kind of educate people always about how this AI really works, but it still does not mean it's not useful. On the contrary, right? We have a lot of problems where a lot of data is all around us, where we could probably use that help in testing, in test automation specifically. So again, I would just kind of throw that back and say, think about it where you have enormous amounts of data and security testing, where you need systems to learn and to analyze or kind of help you in doing decision making, right? And think of it as an assistive tool in making these decisions much faster and much better, in the near future. And again, there's so many technologies that allow you to do this stuff. And it's all open source, right? I mean, this is the other kind of interesting other dimension about this AI technology is that most of the stuff, all these kind of deep learning systems that Google, Facebook, and Microsoft has, they're at the end open source, available, right? Cortana, TensorFlow, what are the other ones? I mean, there's like, a bunch of, 5 different, really big frameworks also for natural language processing, a lot of stuff available. Nobody has to implement that from scratch. Right? So it's very exciting time for the tool makers to figure also out like how can they use which pieces to put it together. So it's very exciting time. So expect to see, especially I would say in this year, a lot of, again, the AI coming out in the test automation tools, but again, it will be like MBT, right? So a lot of people will, of course, tell you that there's AI in that system, but then the question is, you always need to ask, so what do you mean, how you're using it, right? And for what purpose, right? So you will have probably a wide range of answers. But I think it's all very good, and it's like MBT, another kind of technology step in the test automation field that I would say is coming now very strong.
Is there any enterprises that are a bit more far than other one in this automation of testing? So at the moment.
Well, I mean, so from my point of view, I've been talking. In the enterprise IT space, it's not that the company, it's outsourced usually, right? So they say it's not our product. So I'll make like when you build a road, they say like, here, we need these web applications to be implemented and tested. Now you guys start bidding. Right? And this is how it works. And then you have these kind of top 10 gigantic companies, like Tata Consultant Systems, Tech Mahindra, Cognizant, HCL, there's like 10 major, especially in India, right? A lot of companies that then take these projects, bid for them, and then do the testing. And all the company sees is the check, right? And of course, the delivery, of course, that their system is working, but it's like a service. Testing is a complete service. And the interesting part is that has been amazingly, that these guys are so much in competition that they're really wanting to use all the latest technology. So it's not for them like, oh, I have more people, I have cheaper people. This time is over, right? They need technology to differentiate themselves. And as you see with these billions of dollars, it's a gigantic market. So, of course, the enterprises that the testing is being done for, they of course listen to this too. And if the testing service provider comes like, look, we use automatic test design and AI for a test, for analyzing our test execution results, right? Then they say, oh, this sounds very interesting. But I mean, I would not say it's that the enterprise is going that way. It's also what the service providers are offering. But I mean, when it comes to R&D and how to use our AI in like the development of products, like for example, base stations or network elements, I really have no idea where the things are right now. But I bet you have a lot of tests. At least I think it's a very clear hit to say in the execution analysis space, should be a lot of interest in kind of understanding how to execute the test sets and how to minimize to how to get the most out of the existing test sets. Forget even about how they have been written, just to execute them, right? That management is a very interesting field to get started on.
Not in the testing space, but in the monitoring. So when the product is in production, in live, and then we want to see that if it still works well. Have you seen any specific AI solution in that area?
So I don't have any concrete data on this, but I mean, it sounds a lot also like this virtualization, right? Where people are recording systems. I mean, again, I would imagine that you would record data and then kind of feed that into a system to help you to make decisions. You know, what does it mean for it to work well? You're probably looking for something, right? I mean, and it's qualifying that. That's the whole trick, right? I mean, letting the AI figure out, like, you know, what's going on is almost a secondary thing, right? But I mean, the trick is how to formulate the problem, right? What is it that you actually want to get done? That's the key trick here. And yes, I mean, again, everywhere where you have a boatload of data, it should pop to your head and say, like, here, we should be able to leverage this technology here. Right, and see, in my case that I've been describing for automation, we have thousands of manual tests, thousands of different languages, you know, and so there's so much data there that it screams for this kind of thing. And again, the handling of natural language, you know, can also simplify, you know, our interfaces, you know, in a lot of ways. So this is why we see also other products like the websites or something starting to come up with these, you know, chatbots and everything else. This is also driven by the NLP and the, you know, AI in that. So it's an interesting time right now. Thank you so much. Thanks for bearing with me.